Hi, good evening, good afternoon, good morning, depending where you are. Welcome to our session on multimodal user interface on iMX RT crossover MCUs. We have Patrick Kennedy from NXP here as our expert speaker. We have now rolled the Q&A and the main session into this one session, so you can ask your questions through the chat interface. But now I'll hand over to Patrick. Over to you.
Great, thanks very much. Yeah, so getting started for today, I just want to start off to say, hey everyone, thanks for joining today's session. We'll be covering multimodal user interfaces on iMX RT crossover MCUs. As mentioned, my name is Patrick Kennedy, and I really focus on IoT applications in the edge processing group at NXP. So this is really a group that focuses on more of our microprocessors or microcontrollers, as implied by the name. But so this is a relatively short session. So without further ado, let's go ahead and get started. Okay, so the goals for today really, ultimately come down to, how can we learn how to build better products, more specifically, better user interfaces for those really embedded products is really what we'll be focusing on. Especially considering the fact that these are that MCUs in particular are typically highly constrained devices, and as highly constrained devices that are typically a little bit more cost sensitive at times, really the goal is to simultaneously improve the user interface or really the user experience while maintaining or really improving upon the existing engineering and business requirements, right? So those are your typical questions of cost, power, performance, and it's really this fine balance, really a trade-off between the two a lot of the times, right? So the question is, well, how do we do this, right? And so in terms of providing a better user interface, really can come down to really three key things that we can really focus on, right? One is flexibility, and really what that means in this case is permitting end users to modify or add new functionalities or access existing functionalities through a preferred medium or mode, and we'll kind of discuss the differences between those two things in a little bit. But really, what the idea is to provide a high degree of personalization of the device to a specific user. So an easy example of this, right, it would be with modern digital thermostats, which are becoming increasingly common and prevalent throughout homes, residential spaces, even commercial spaces, right? Being able to set specific schedules, right, where you can decide exactly when the thermostat turns on and off, and personalize it to your specific desires, let's just say. Another one that's a little bit more simple that you're starting to see across a wide range of UIs, not just in terms of in web browsers, but even embedded devices, is being able to change, say, the background, similar to how users could customize in the past, right, the wallpaper of their desktop. And so in some cases, this is really, in some cases it's functional, in other cases it's more aesthetic, but it still has a big impact in obviously the satisfaction and really being able to optimize a device as per the user's preferences, right? Okay, so second is usability, right? So that's essentially the capacity of a system to really provide a condition for its users to perform these tasks, really the defined tasks, not only safely, effectively, and efficiently, of course, but really with a high degree of satisfaction, right? And that's really what lets people not only learn how to do something, but keep them coming back to a specific product and also learn how to use it actually really more efficiently. And many times this requires a lot of iterative design, right? I mean, it's rare that you'll have something right out of the gate that really just is exactly perfectly usable for the end user. And so having some flexibility in testing and really upgrading your UI is similarly increasingly important. And then thirdly is finally is accessibility, right? Which really is more of a measure of how well users of a diverse abilities or backgrounds may navigate and understand and even use your UI, right? So, and this can be either kind of environmental influences or even personal influences, right? So that could include people with traditionally accessibility is thought of in terms of perhaps the maybe in terms of providing accessibility for users with certain, say, disabilities. But really that extends beyond that to, in many cases, there's environmental influences that might in many cases already be occupying, let's say, the user's other senses, or there might be some reason that they, cannot, for example, be right next to the device they're actually interacting with, or perhaps, they're in another example would be in a very loud environment. And so really the key is actually increasing all of these components in a lot of cases, which can really provide a really improved specialized user interface. Of course, fitting all of these components together, is really on the task of the designer. But generally speaking, certainly having a more flexible, usable, and accessible interface all at the same time can provide a lot of benefits. And one really great way to do this, as you might have already guessed, is through multimodal user interfaces, right? And so really what we can ask ourselves is not only the approach, which we've already defined, but really what are the right tools for the right tools for the right job, or really the right tools for our application when we're taking this approach. So to get a little bit more into the actual, let's say, concept of multimodal UIs before we get a little bit more into the right tools, to kind of define a few key terms, right? So in terms of multimodal UIs, we have to look at one, modalities, and two is mediums or media, right? So we can think of modalities as a single independent channel, really of not only sensory input and output between in this case a computing device and a human, but really it's the focus of how certain information is encoded. And what we mean by that is, in the case of let's say natural language, right? We have things like spoken language, we have things like written language, we have things like Braille or even sign language. In each of those, really are a language in and of themselves, but they are accessed through a variety of media, let's just say, right? So an example might be where this might actually happen is a karaoke machine, right? Where there might be a music modality across really the audio media, while there is a written language across the visual media. And many times, really what you'll find is that increasingly, we blend several modalities across several media, right, increasingly, which means we need in a lot of cases, we need hardware that can support a variety of interfaces, graphics, responsiveness, and while still maintaining the latency and responsiveness in a cost-efficient manner, right? So in many cases, we might have auditory media where we have things like music or noises. So that would be more like alarms, or even for example, when you're using a touch screen and you want the user to experience like let's say a click, just so they know that the screen is actually sensing their fingers and their gestures. Across visual media, we might have things like, as I mentioned before, written language, as well as images or even icons and symbols, right? You'll see this very commonly, for example, when looking at some weather reports, right? It includes a variety of modalities that we can visually see, but also it really reinforces our understanding rather quickly and intuitively. In terms of, and then we also have tactile media, of course, which we had discussed a little bit before in terms of Braille, haptics, and even gestures, such as, for example, sliders in terms of a touch interface on a touchscreen. And then finally, increasingly, we're seeing things are really multimodal UIs across really what we call kinetic media. In many ways, it's invisible to us as the users. So a really good example of this, right, is a lot of newer thermostats, for example, is you walk up to them and before you even get to the interface, the screen turns itself on because it recognizes that you're approaching the interface, and more than likely you are about to do something. A lot of phones nowadays do something similar, although it's typically more of a really more of a recognition on gesture, but you can kind of get the idea that it's becoming more and more understanding of not just our auditory, visual, tactile, and tactile, let's say, media and the associated, let's say, languages or information we purposefully encode across those media, but even some more of the, let's say, beneath the surface body language that we subconsciously give off. So we can see a lot of these UIs are actually starting to incorporate this, right? If we look at the past, present, and future of, as I mentioned before, an easy example is the thermostat, right? Ranging from way in the past, excuse me, this is way in the past, with the case of an analog interface that consisted of a very basic dial, perhaps a couple of switches and maybe even a push button, and really no indication of whether where we are in relation to the current temperature. Then we move on to something with a little bit more, not only a little bit more information encoded on the screens in terms of a menu system, but also alphanumeric qualities, as well as kind of more of a monochrome kind of LCD display. And then finally, as where we are in the present day, right, is things are starting to get moderately more complex as we start to introduce really more graphical elements, animations, a bit higher resolution, full color displays, perhaps even touchscreen LCDs, where we even implement things like voice control. Starting to see a lot of those come out nowadays, and some of those natural or, let's say, invisible UIs that go across that kinetic media. So really the idea is that as these UIs become increasingly, as I mentioned before, multimodal, basically they're encoding more and more information across really more and more media, and they become highly interactive, and really that increases basically the bandwidth across the bandwidth between the user and the machine. We need hardware and really software frameworks that can support a scalable and efficient means of providing that interface while still maintaining something that is really cost effective. And so NXP actually on our end is we have a pretty wide variety of processors across our portfolio, and one of the areas where we're seeing a lot of utilization in these specific applications that have that have to walk this fine balance of providing highly interactive UIs, but while still maintaining specifically lower power or cost optimized BOMs. Really, that's where we see a lot of these solutions being built on. It really provides a nice combination of functional integration and performance, and it really can be applied to and it currently is being applied to a lot of different target applications, ranging from voice and audio solutions to healthcare and consumer applications, to things like home and building automation. Obviously, with digital thermostats being a key example there that we already covered. And then, of course, we can get more into things like industrial computing and motor control and power conversion, which increasingly are needing their own sophisticated user interfaces, because really we're starting to realize as well that as automation really starts to pick up, there is a real business case for UIs that are intuitive and also prevent accidents and maintenance, even in required maintenance, even in industrial settings. So really the idea with the RT series of the i.MX RT crossover series MCUs is to provide a lower bill of material costs with a large internal SRAM. So really it's the idea of providing a lower bill of materials cost that's typically associated with an MCU or a microcontroller, while really providing a high level of functional integration, which is covered from a very high level here, and that is more similar to what we would think of as in terms of an applications processor, right? Where we have, even on some of these newer devices, which we're going to focus on for today, we have integrated 2D GPUs and heterogeneous graphics processing engines. So looking a little bit more specifically at the 1170, especially given that we're really most interested in graphics for today, we can kind of see that really it provides as I mentioned before, a heterogeneous graphics solution that supports not only multiple displays, but really a means of providing overlays on those displays, which is very, very typical, as I mentioned before, of some of these newer UIs where you're blending not only, for example, images, right? So images in terms of, say, a JPEG or what have you, but perhaps you're even blending incoming camera streams or other visual media. And really what it means is not only can we provide a really interactive display, or let's say interface between the user and the embedded device, but we can do so with a scalability across a variety of different resolutions, right? Not only through the multiple display interfaces that it offers, which gives some flexibility in choosing what displays to design with, but also with the embedded 2D GPU, which essentially supports OpenVG, the OpenVG 1.1 API, as well as a variety of vector graphics functions, right? So that includes things like rasterization, transformation, path and stroke generation, fill rules, transparency, and really it can target a lot of applications where you need to work with SVG and Adobe Flash viewers. You can build portable mapping applications, which are increasingly being embedded on GPS watches and smartwatches. And it really allows for the development of what we call scalable user interfaces. And the reason it can do that is really a big part of that is through the flexibility it gives in dealing with some of these vector graphics. So most of you are probably familiar with the fact that vector graphics uses geometrical primitives, basically mathematical equations, right, to represent images within computer graphics, which at least in the world of let's say microcontrollers, is quite different from what is traditionally used as raster graphics, right, where we're just having a collection of pixels. And really it means that we are able to have lossless resizing and stretching. So for example, if you're displaying some kind of graph or chart to a user, they can zoom in and zoom out as needed, maybe based on their, this is kind of an eye to accessibility in terms of, what they are capable of. But additionally, it looks better on devices with higher resolution, and we don't need to worry about, a loss in performance or even the quality of our UI if we say need to move from one resolution to another as we create new devices. It also means that we can represent all of our images many times with significantly less memory. And it even means that as your assets go across various devices, especially in today's modern world where many of these embedded devices have an associated app, it provides a scalable means of maintaining your logo and brand and your brand feel, if you will, right? So that users can really identify that, rather that your application, let's say if you have an associated mobile application or even a website, it has the same look and feel as your device itself. So it really provides a means of scaling your product and across multiple domains. These devices, a lot of them also include, especially the 1170, really includes some additional graphics acceleration in the form of a pixel pipeline. So that includes really bitblit, some flexible image composition options, color space conversion. And really the nice thing is that all of this hardware is is enabled with many of our partners, including Qt. So really what it means is not only do you have access to some high performance graphics processing, but it's accessible through all of the similar frameworks that many of you are already familiar with, including Qt and a number of our other partners. So that being said, in terms of still maintaining the performance and low power and really the typical engineering requirements that we discussed previously, really a big part of the benefit of these devices as well is in the dual core architecture of the device. Basically in the fact that it contains a Cortex M7 running up to 1 gigahertz, so it's very, very high performance. It's actually really by and large the most really the highest performing Cortex M7 on the market today. But it additionally includes a 400 megahertz Cortex M4, which is really more power optimized and can additionally focus on some of the more control functions. So what it means is that really you can choose to, basically optimize the device and use the right core for the right function, I should say, rather, right? So a very good example of this again is for digital thermostats and even for even home security control systems. Many of them still require their power budget is actually relatively low, which comes as a surprise to many, and I know it did for me, especially because they, especially in more of security panel systems, even in residential areas, need to basically be able to survive off of battery in case of a power failure. And so really what this means is that it provides a way of partitioning your graphics and UI functionality to something that's a little bit more high performance, like the M7, where maybe you don't need your display always on and being updated, where you have UI maintenance going on. So you can put that to sleep, while the Cortex M4 can kind of do some basic housekeeping and whatnot. So additionally, I know we had talked about as well with multimodal kind of interfaces. There's a variety of other interfaces beyond just graphics, let's say enablement that is required. And one of the things that's available on the RT1170 is MIPI CSI and DSI. And this is, in addition to the parallel interface, which is not as new, but additionally, it does provide some flexibility, especially since it's power optimized. And so really what this means is that, again, you have you have the right hardware to access the right interfaces and the right media and modes for your application. It also includes an LCD interface, or a slightly new variant of our LCD interface that essentially supports alpha blending. It supports alpha blending directly from really one of the camera interfaces, right? So we see a lot of applications nowadays where you have some kind of video feed where perhaps you're doing, let's say, some kind of, in some cases, machine learning, or in many cases, you just want to add a filter on top of the image. In this case, it can do it basically all in hardware, right? Which means you can have a lot less power consumption, or you can use a lot more of that processing power for driving another display or working with other media or other modes within the same media. That being said, we do still have our typical CMOS sensor interfaces, as I mentioned before, that support a variety of formats for really always improving the formats we support, as well as the resolution and input rates. And then finally, to finish it off, the device also includes an audio subsystem as well for some of those voice and audio applications that I discussed previously. Really, not only supporting your typical SAI and SPDIF interfaces, but it even includes a digital microphone interface, which basically allows you to connect directly to PDM microphones. So not only does it reduce cost in your BOM, but it actually includes a hardware voice activity detection module, meaning you can sort of basically you can provide a wake up for, say, the M7 core upon basically hearing some sort of human voice activity proximal to the device. So that being said, I think I'm going to go ahead and open it up to questions. I know I'm a little bit over time, but hopefully you guys found this interesting, and I look forward to getting some feedback and hearing if anyone has questions. Thanks very much.
Great, thank you, Patrick. So as mentioned in the chat comments, please send your questions to the chat functionality. I believe the Q&A is not functioning properly for this session, so we'll wait for a little bit to get your questions.
Yeah, I guess kind of I'm not seeing any questions on my end, but
yeah, so I think people didn't quite hear me. So just a reminder that I think the Q&A functionality didn't quite work on this session. So please send your questions through the chat. So we'll be here for a couple more minutes.
Yeah, and if there aren't any, I guess some of you are maybe thinking of questions or maybe considering some stuff. I'm curious to get some feedback from any of the participants. Is what new trends do you see in terms of whether it's multimedia or multimodal, interfaces? What are some of the more interesting ones you've either worked with?
I think there's a question now from Bruce.
Yes, I'm seeing that. So the question is, looking at the NXP website, is this the device we're talking about? Basically, is it the RT1170? Yes, it is. I'm going to go ahead and drop the actual link of this into the chat just to make sure that it's a little bit more clear. But yes, that is correct. It is the iMX RT1170-EVK. The evaluation kit that Bruce is mentioning.
We've got a few more minutes, so we'll wait a little bit longer before we stop the broadcast. But in the meantime, I'd like to thank Patrick for the great presentation and everyone for joining. But we'll hang around for a little bit longer in case someone is typing. Okay, it doesn't look like there are any more questions for today. So thank you again, and have a good evening or day wherever you are. Thanks.
Thanks very much.